Hello, today we are going to visualize some sorting algorithms using C++ Raylib. Hope you guys enjoy it. So let's get started. Let's import some important libraries for today's project and let's define some constants to use. We shall be sorting the bars of different heights. Let's make up the initial setup of the game. Here, we are going to initialize the window with our width and height and give it a title. We set the frames per second for the display, and since we shall be sorting, we need to seed the random number generator, and we start our game loop. We shall draw some stuff in here, and we shall use the dark background. After drawing, we end the drawing and we close the window, and it will be done. So let's define the structure of the bar. It will have a color and height. Let's declare an array to hold the bars. Then we initialize the bars. For initializing the bars, for every bar we shall assign a random height and a color. I prefer gray. Let's define also a simple function to draw the bars. We shall use the sorting algorithms, so we need a way to update them according to the user's command. Before we do that, let's first define some more stuff. An enum for the sorting algorithms being considered at that time. The name of the sorting algorithms. And a variable to hold the value of the presently selected algorithm. So for the updated algorithm function, if a key is pressed, in our update algorithm function, we update the working algorithm and reset the bars. 1 will be for bubble sort, 2 for the selection sort, 3 for the insertion sort, and 4 for the quick sort, which is my favorite. More algorithms can be added here with similar key bindings for the expansion. This helps us in a way that in our main function, if an algorithm is selected, we call the appropriate function for that. We can also display the names of the selected algorithm down here. Let's first define all the functions we shall be using. Do the bubble sort. Bubble sort works by repeatedly swapping adjacent bars if they are out of order. It is called bubble sort because the largest bar gradually bubbles to the top after each pass. We will visualize this by highlighting the bars being compared and swapped. We need two indices, I for the current pass and j for the position of the bars being compared. If the height of the bar j is greater than the bar at j plus 1, we swap them. After every pass, when j reaches the end of the unsorted portion, the largest bar in that pass is put in its correct position. We repeat this process until all bars are sorted. And let's see how things are so far. Great. Next up is the selection sort. This algorithm works by repeatedly selecting the smallest bar from the unsorted portion of the array and swapping it with the first bar in the portion. It's like sorting cards, but always picking out the smallest card you find and placing it in the right spot. So we use an outer loop I to track the current position in the array where the smallest bar will be placed. For each position, we search for the smallest bar in the unsorted portion from I to the end of the array. Once we find the smallest bar, we swap it with the bar at position I. Repeat this process for all bars until they are all sorted. Let's see how things are doing. So far, great. Now let's implement the insertion sort. Unlike bubble or selection sort, insertion sort works by building the sorted portion of the array incrementally, one bar at a time, placing each bar in its correct position relative to already sorted portion. We start with the second bar, I is equaling to 1, treating the first bar as already sorted. Take the current bar and compare it with bars in the sorted portion. Shift all larger bars one position to the right, making space for the current bar. Insert the current bar in the position within the sorted portion such that it's in the right position. Repeat this for all the bars until the array is sorted. So let's go check the result. Great. So finally, let's do a quick sort. Quicksort is a divide and conquer algorithm that works by partitioning the array around the pivot element. After each partitioning step, all bars smaller than the pivot are moved to its left, and all bars larger than the pivot are moved to its right. The process is recursive and repeated for the left and the right partitions until the array is sorted. For visualization, we shall handle quicksort iteratively using a stack to avoid recursion complications during the visualizations. Let's go check it out for the results. Great. And thanks guys for watching. Hope you enjoy it. Please like and subscribe for more. I love you all.